Is going to be on partition labels, which is a Leetcode question. So here's a question, right? So you're given a string S and you want to partition the string into as many parts as possible, such that each letter in the whole string appears at most in one part. So let's see what this means, right? So let's say we have the string ABABCC, right? And let's say you want to partition the string at this index. So we get ABAB and CC. That is okay because A is only in this partition, it's not here. B is only here, not here. C is not here, but C is here. So that's okay. But you can't do something like, you can't partition it like this, where you get second segment of B because B is in the first segment. So how do you go about solving this problem, right? So before that, let's look at one of the inputs so we can think of a solution, right? So here is the input, and then notice that the three substrings which which are one feasible partitioning output is these three, right? So what do you notice in all of these three strings, right? Yeah, the thing that answers the question is the fact that a character does not appear in more than one string, right? It's like, for example, B only appears here, it does not appear anywhere else. And secondly, let's see which of the letters are actually important for us to get the solution. What I mean by that is, like, let's take letter A for example, right? When do you know that a partition that contains the letter A will be the minimum sufficient partition, right? For example, we look at this A here, it starts off with an A, so you know that the partition that this A is going to be in has to be a partition that includes A and that A. So what this will tell us is that we need the first A in the string and the last appearing A in the string, and we need to know that these two have to be in the same partition. So which is why let us do A being here and A being here, right? And if you look at other letters like B and C, the same logic holds, right? You have B here and the last B is here, right? So that's fine because they're in the same partition from this A to this A. Similarly, C is the same. The first C is here and the last C in the string is here, which is why the string is fine. If you look at the second partition, you will notice that we start at D and then we end at E here, right? Notice that the first D starts here and then the last D ends here, right? So typically this would mean that, like, maybe you can just take this D and make it a segment, right? But no, that would not work because you have to look at E. There's a E here, but the last E is going to be over here, right? Which is why you cannot just do that. So you have to include the index of the last E as well. So it's a similar logic for the last one, right? We see H there. Even though it's the last H there, we have to go all the way until J because there's a J here, right? Which is after the H. So what does this problem remind us of, right? So how can we go about thinking of this problem? This can be thought of as a merging intervals kind of question, right? You're trying to, with a given string, you're trying to create intervals such that each interval is mutually exclusive, right? In the sense that, like, I can have an interval here and it does not overlap with this interval here, right? So that's the idea of, like, how we ultimately have to solve this problem. So what we do is you have to find for each letter the earliest index in which it appears in the main string and the last index in which it appears in the main string, and then you create a interval out of that. So for example, A, right? A is going to have an interval of 0 and 8, right? And then B is going to have an interval of 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5, right? 5. So let's say if we just had this, let's say if we merge these intervals together, it is ultimately going to be 0 and 8, right? in a similar way, yeah, we can do it in a similar way for the rest as well. We look at this string, right? I'll just reset to 0 index, right? So you look at D, which the earliest one appears at 0, and the last D appears at 0, 1, 2, 3, 4, 5, 5, right? And let's look at E. The earliest index begins at E, and last index finishes at 0, 1, 2, 3, 4, 5, 6, right? So if you were to merge these two intervals, we will ultimately get 0 and 6, which is how we end up with this this substring. So that's like the core idea of how you solve the problem, right? So ultimately, for each character, you need to get the first and last indices of that, the earliest and latest like appearance of that index, and then just need to merge the intervals, and then get the length of intervals.